Yeah, so Ryan McIntyre, hey everybody. I'm the,
Did I put my right name on there? Is that what you just said?
I didn't know if I put my name on there.
Oh.
I did put my right name, correct name. I don't just do technical help for conferences. My main job is a cloud solution architect for Microsoft. I work with a partner-focused organization inside Microsoft that works with Microsoft partners, all about helping them for really two main areas that I focus on. One is for ISV partners, a partner that's building an application that they're going to then sell to their customers. Maybe that's a SaaS application or an app that's running on a Windows device or a phone or an Android device or whatever. And they need a place to host that. I help them figure out how to host it on Azure and get it running in the right way. I also work with SI partners, so your consulting partners. So if any of you work with a consulting company, and you want to work with Microsoft, SI is a term that you'll get familiar with, it stands for Systems Integrator. So I help those partners build practices and offerings for delivering those solutions to their customers, targeting Azure. So what I wanted to talk to you about today was an area that a lot of the partners that I work with focus on when it comes to building their applications. And the consulting companies that I work with, their customers are interested in learning about this stuff. So Jason asked me if I wanted to present anything. I thought this would be a good topic since it wasn't being covered in depth anywhere else. Honestly, I didn't really have a whole lot of mindset as far as what direction I wanted to take you all down as far as the path is concerned. I really was hoping that you guys could contribute to some of that. So let's start with maybe just help me get an understanding of what your understanding of containers are. Who knows what containers are? I'm not talking about boxes or shipping crates or anything like that, right? So containers from an application development perspective, who knows what those are? You can't point to somebody else. He pointed to you, by the way. All right, keep your hands up. Okay, so for you, keep your hands up. So for those who know what containers are, keep your hand up. Who has built an application using a container? Keep your hands up.
Today.
Production app or just
any app? Yeah, it doesn't have to be production. You've built an application, put it into a container, and you ran it. Maybe even just on your laptop.
Only in the lab today.
That counts.
That counts.
Lab count?
If you did the container portion of the lab, yeah.
Okay. How weird is it that I've done it, but I can't define it?
That's all right.
Because I had my hand down the first question. I'm like, well, I kind of, but not
That's
really.
all right.
And then if you done one, well, yeah, I've done one, but I don't know what it means.
Yeah, labs will do that, right? They'll kind of walk you through steps of doing something, but there isn't always the underlying education of what the hell am I doing? Or why am I doing it? That's kind of a good and bad thing for a lab. But so for the ones who've done things in containers, now who's done production container? An app running in production in a container. All right, let me ask a different question. Who has deployed an application in a container into an orchestration service, such as Kubernetes, Service Fabric, Docker Swarm, VCOS? A few other folks. Okay, so based off of the first answer, I'm going to dive into just kind of a quick Containers 101. For those of you who did the labs, I think this will start to help answer what containers are and why we're going to be using them. So I'll breeze through some of this stuff. I'm a technical guy. I'm not a marketing guy. I didn't come up with these slides. I'm not going to take credit for them. They're fancy. They have movement, but they have a good message on them, so I want to go through a few of them. Containers really came from the need for development to work with IT and vice versa. And traditionally, when a developer, which is my background, so me as a developer, I would develop an application. I need to host that somewhere. I need to get it up and running so that I can have users access it. I can develop it on my laptop all I want. I need to work with IT to have them get the server provisioned, to get a network for that server to sit in, to expose ports, to set up firewall rules, etc. I never had access to that in the companies that, at least me, that I worked for, except for the time when I had my own company and I was the only one doing everything. So containers are a solution to help that particular problem, with IT and developers needing to be able to work together and to coordinate what they're actually working on. So this is kind of some words around the development side, from the IT side. Press the right button. So from the IT side, they want to make sure that what they're getting from the development team is solid, it's going to work. They want to make sure that what they're deploying in their environment is as close to what the development team built, and they want to have something that's going to be repeatable, right? If any of y'all are quote unquote IT folks, meaning you work with servers, you work with networks, you work with storage, things like that. That's what I mean by IT. Any of those folks who are in those roles, you want to make sure that things are going to be repeatable. When you do things, when you follow a certain step, a process of steps, at the end of that, you should have the same thing if you go through it again and again and again. Right? When I used to develop apps 20 years ago, if I gave you that app and you ran through those same steps, you may or may not get the same result depending on what that code was. So containers they try to help solve that problem where you just have this one thing that runs the same in different environments. So hopefully this will answer the question of kind of what a container is and where it lies in this infrastructure. So let's start here actually. So most folks know what a VM is, right? You have a physical host, you have a physical machine, and then sitting on top of that are some virtual machines. And you can have one to end, depending on the capacity of your physical host, VMs running in that. So I could have, this could be, a Dell machine sitting in my data center running Windows Server 2016. These all could be different VMs. Maybe this is Server 2012. Maybe this is Server 2016. Whatever. Then my application gets deployed into each of those specific VMs. Right, so pretty isolated here, right? This guy, unless I do some networking at this layer, this guy can't talk to this guy. Right, it's probably a world that most folks are pretty familiar with or came from. Now jumping over here, the analogous conversation for containers, really, it just kind of moves this box of a VM, and what it does is it makes the kernel move up a level to where it's now shared. Now, it doesn't mean that when the containers sit on top of that kernel, they can talk to each other. Right? There's still networking that needs to go on there. But what this does is it makes these very lightweight. They don't need to carry a full OS with them anymore. They don't need to carry a full kernel with them anymore because they're sharing the kernel from the host. So now this thing, VMs, when we would build these, especially Windows, right? What's the size of a Windows VM server? Sorry?
1 gigabyte.
Depends
1
if it's
gigabyte?
10 or you take provisioning. I mean,
Anywhere from 1 gigabyte. What's the largest VM that anybody's seen?
256.
Go out to Microsoft's Azure.
256 gigabytes?
You mean on the memory?
Or no.
Disk.
Disk, yeah.
just have terabytes.
Oh.
I mean, actually,
Well,
petabytes, yeah.
Petabyte.
When it's connected to multiple
Oh, memory 4 terabytes. I'm just thinking about the VHD file.
I've seen
Large, right?
hundreds of terabytes.
Yeah, so those things can get large. So most of that, well, except for maybe all the storage and extra stuff that your app does, that's now shared, right? Everything with Windows Server 2016, if we're talking in the Windows world, or maybe on the Linux side, Ubuntu, that's all shared. Everything that's in this container is just your app. So the only thing in that container are, if it's a Node app, all of your files for your node application, maybe some data files if you're doing some data initialization for your app. There's nothing else around the OS because it shares it with the kernel. Does that make sense? Does that help kind of answer how containers fit?
But how does it compress the capacity of each container?
So that kind of gets into how we set up, not necessarily our application, but how we deploy the container into a host. So when we deploy it, and I'll talk about the different ways we can do that. When you deploy a container into a host, and I'm using a vague word there, host, for a reason, which you'll understand later. We can define this container needs 1 CPU and 4 gigs of RAM. Whatever those numbers are, we can tell that host what those things are, and it'll work within those constraints. Does that answer your question?
Yeah.
Okay. Windows has this weird, not weird. It's actually pretty nice, so I don't mean to be negative. But so Windows containers, forget the word Windows is there. This diagram works with Windows or Linux, right? You have a host, you have hardware with an OS, and then you have containers that sit on top of it. Linux or Windows, doesn't matter. On the Windows side, the Windows folks took things a little bit further because they had this concept of technology of Hyper-V. So what they did is they took the concept of containers, the technology of Hyper-V, and they merged them to the point where now you can have a container, which is still a Docker container, but it moves the kernel from this level down to the container. So I just talked about a bunch of benefits as to why you go from here to there. Why the hell would we come back down here? Security. Right? There are a lot of folks who build applications that you want to make sure that there is no crossbreeding. There's no ones and zeros going from this kernel to this kernel. They can't work in that environment. They can work, but they're not compliant with their security policies, as an example. So they have to do something like this. So this is another type of container that you'll hear about, Hyper-V containers. This is only in the Windows world. Yes?
So if the container is our application code, where does the image fit into it?
The image, like a VHD image?
No, I have the Linux image, which comes with whatever else dependencies I want with it, right? Where does that fit in here, in your diagram?
So what is actually running on the VM?
Yeah, like what the dependencies of my container, where does that fit in on this architecture?
So they'll be defined in your container. You'll say, for this, say this is a Linux container running on a Linux box. So this is a CentOS machine. So this is just like a base CentOS server. In this container, we can say this container needs, maybe it's Python, right? So we need to have Python installed. That'll be defined in the definition of that container. Maybe that Python needs Flask, so it'll install Flask. Maybe it needs to run a certain command to go download some software. That'll all be defined in the definition of the container. It's called a Docker file. So each of those things to define what those dependencies are for that container live in that Docker file. And then when the host fires it up, it just runs through each of those steps and executes them, installs the software, whatever it needs. But it's only in that container. It doesn't install it down here.
So an image isn't in memory, right? An image you're going to keep on a registry, and then you may instantiate it in memory here. Does that make sense?
It does, yeah.
An image is not a live container. You've just built an image in your Docker file. You typically put it in something called a container registry, and then from there you pull it and load it there or there or there.
Right.
So a container in memory is just a container, but an image isn't really in memory. It's just a set of files that define what it looks like.
Yeah. And it's a set of files that layer on top of everything else, right? So think of layers. When you try to think about how containers work, you have this layer of the host, you have this layer of the kernel, and then you have the layer of your application. And within there, you could have multiple layers, right? My image could be I want to start with an Ubuntu image. And then on top of that, I want to have an Nginx image. And on top of that, I want to have my custom application. Right, so it's all layers, one on top of the other, getting more precise. Okay. So I'm gonna skip a bunch of stuff. I guess before I do, does that kind of help lay a foundation for what containers are and how they work? A couple nods. Are there any shakes?
Yeah, makes sense.
Yes, sir.
Question. Compared to Docker Swarm or something like that, Hyper-V is completely different. They are not portable.
They are two different things.
Two different things.
Yes. Yeah. Docker Swarm is it's an example of something else that I'll talk about. It's used to orchestrate hosting of containers.
What I meant by it is it's not a Hyper-V container, so not same as Docker containers.
Correct.
You cannot use Kubernetes or Docker Swarm to orchestrate Hyper-V.
Not yet. So I know Docker has Windows support. I don't think they have Hyper-V Windows support yet.
Yes, that's it.
Is that kind of okay? So yeah, it's up to those vendors to support those technologies. So when we start talking about some of the things that are in Azure and how Azure runs containers, whatever those vendors support is what Azure is going to support. So Microsoft's not building anything fancy with the exception of three things for containers. Like with Kubernetes, right? We have 3 different services that are built around Kubernetes. We didn't fork Kubernetes. Kubernetes is open source. So we didn't fork Kubernetes and come up with our own Microsoft version of Kubernetes, right? We have engineers contributing to open source Kubernetes, and when the features get built in, we'll pull that into Azure and then build our services on top of that. So whenever Kubernetes supports Windows, they have beta support for it right now. Whenever they fully support Windows, Kubernetes on Azure will fully support Windows. Same thing with Docker Swarm. All right, so let me jump to here, if this works. If my computer doesn't blow up, I'm going to be amazed because it's doing all this video. I've been recording everything on this laptop, and it's doing all the encoding right now. Okay. So now jumping into, okay, we have this awesome container. We built an app. We containerized it. You're running on, yeah, so we're running it on our Macs or whatever device we have locally in Docker. Works great. Now we want to collaborate with teammates, or we want to publish it and get it out to the world. So here's some different ways that Azure will help you do that. Everything. So pretty much everything from here over are the different ways that we can host containers inside Azure. So starting over here, I believe it was you, somebody mentioned a registry, right? A place to store our containers. Azure has an Azure Container Registry, which is you can think of a registry as a place, as a library of containers. So you build this awesome app, you want to publish it somewhere so other people can use it, or you can use one of these other services to pull it down and host it. That's a registry. Azure has one, AWS has one, Google has one, Docker has one that's public, hub.docker.com. If you want to be more private, Azure has one called Azure Container Registry, part of the Azure service. So we would publish our container here. Then we need to figure out how we want to host our container. We have traditional options down here. We can create a virtual machine, just a VM running up in Azure, and we can install Docker on it. If it's a Linux machine, or if it's a Windows Server 2016 image, we can create a VM that there's a specific SKU for it, Windows Server 2016 with containers, and that includes all the Docker capabilities. We could use one of those. Yeah.
I have a question. Can we use web app for that?
We can. Yep, is that not up here? Yeah.
Oh.
Yeah, web app is part of app service. Yep. Virtual machine scale sets. It's just a nice way of grouping VMs and creating high availability. We can go more into that later. I won't dive into it now because it's not a traditional approach. Azure Batch is something that's used for a lot of data processing, moving data around different locations. Containers can be used there. Really, the ones that we tend to see are here, right? App Service, which is a web app, like the gentleman said. Service Fabric is a platform that Microsoft built. Oh, geez. Probably, well, they built it to build Azure. So whenever they started building Azure, that was 12, 15 years ago, that's when they came up with this thing. Since then, they decided that it'd be a good idea to make this available to other folks and not just hoard it. So they got to a point where they could publish it out, and it's now a service that you can use on Azure, and you can host your applications on your own Service Fabric cluster.
Didn't IBM create containers? Like they invented them?
Now, when you say create containers,
Invented them.
right, it depends on what we're saying a container is, because the idea of a container goes way back to mainframe IBM days.
Right.
Yeah. When did it actually become a term where somebody like Ryan comes up here and has a talk about containers?
Right.
That was probably Docker who came up with that.
Gotcha.
When they came into existence. But yeah, the concept of containers have been around forever. So Service Fabric, a platform that Microsoft built that's now available, recently open sourced, so it's open source now.
It's open source now?
It is. Yep. Yeah, as of maybe a month ago. Yeah.
Which one is the least expensive?
So many variables go into that.
It depends.
Yeah. In a scenario where you say have one container and I just want to run it and test it out, and then I'm going to pull it down. This guy.
Azure Container Instances.
Yeah, Azure Container Instances. So Azure Container Instances is a service where you can very quickly and very easily, and I'll show you guys this if I have time, just take your container, fire it up, and within a minute, it's up and running. You don't need to worry about any infrastructure. You don't need to worry about Windows, Linux, networking, endpoints, firewall, none of that. Azure, here's my container, give me an endpoint, done. This charges by the second, but if you run this for, say, 24 hours a day for a week, that's going to be more expensive than if you fire up a VM and run that.
So Microsoft doesn't charge by API calls rather than by the time, right?
Depends on the service. Yeah, so some of these services like Azure Virtual Machines, if I remember right, they charge by the minute now. This guy charges by the second. This guy we don't really know because technically this isn't. Well, not technically, it's not generally available. This is in preview right now, so they haven't finalized the pricing. There's no cost for Service Fabric. Service Fabric, though, sits on top of VM scale sets. So you're paying for the VMs, which means you're paying per minute for all the VMs that are running your service fabric cluster.
That's why you should always have them auto shut down at a certain time, give the user a script to spin them up.
Yeah, if you're doing this like a dev test scenario, yeah, you want to spin them
Save a
down, you
lot of
want to spin them up for sure. Yeah.
Yes.
What does service fabric do
Just-
again? Sorry, I know you mentioned it.
Yeah, sorry, I'm jumping around a little bit, so apologize. Service Fabric is, just think of it as software. When you go into Azure, the Azure portal, and you tell it, I want a new Service Fabric cluster, what it does under the covers is it creates a scale set, VM scale set. So it'll have, say, 5 VMs that are clustered, networked together, and then Service Fabric, the software layer, sits on top of that, and then that's what you use to host your containers. So there's no cost for the Service Fabric piece, but you're paying for the compute for those VMs, and then any storage, and then any kind of related to what you just mentioned about API calls, you're paying a little bit for any data that leaves an Azure region. There's a minimal cost for that, but there's no cost for Service Fabric. AKS, this is what runs Kubernetes. This is Kubernetes in Azure. This will probably, like 99% sure, this is going to be the same, right? There's going to be no cost for this, but you're going to be paying for the underlying infrastructure because this sits on VMs too. So you're going to be paying for any VM, compute time, storage, networking, the data transfer costs. I guess the only one that I haven't touched on here is ACS Engine. ACS Engine is an open source project that leverages Kubernetes. And what it does is, I didn't go through the lab, so did the labs go through ARM templates? No?
Yes.
Okay. Yes?
JSON,
Yeah.
Yeah.
Yeah, they're JSON documents.
which you push out in deployments with PowerShell or.
Yeah, exactly. Yeah, so an ARM template is just a JSON document where you define, here's what my infrastructure looks like. There's a certain way for specifying, say, what type of VM you want, what size disk do you want, what does your networking infrastructure look like, and then that template is used sometimes through PowerShell, sometimes through a CLI to push that into Azure, and then it creates all those things that you told it in your definition file. So ACS Engine is an engine that is used to create a template specifically for creating a Kubernetes infrastructure in Azure. So you tell ACS Engine what size of Kubernetes cluster you want, how many nodes do you want, what size VMs do you want, how do you want your networking set up, right? Using Kubernetes specific language. You don't have to know anything about Azure. And then basically click go, and it'll create these ARM templates for you, which are the Azure language for everything that you told it to build. And then you can take those ARM templates and create an environment.
Where did Kubernetes come from?
Where did Kubernetes come from?
It sounds like Kerberos, but I mean.
It did, yeah. It came from Google. There were 3 guys who worked at Google. Huh?
Enough said.
I don't know where the name itself came from. I've been meaning to ask. So one of those 3 guys now works at Microsoft. His name's Brendan Burns. Been meaning to ask him.
It's a strange word.
But yeah, not sure where it came from. There's a nautical theme that they have going on.
Yeah.
So, yeah.
Any kind of app can be built on containers?
Pretty much any kind of app, unless you tell me that you have like a mainframe thing.
But how about the database layer? Was it also included in the?
You can, yeah. So like for instance, SQL Server, you can run SQL Server in a container, in a Linux container if you want. Now I say you can because maybe you don't want to. So when we think about containers running in one of these environments, that container, say it's running Service Fabric. Here we have a nice little diagram. Say these 5 dots are VMs. Our container might be, our SQL container might be running here. One of the things that these services do, Kubernetes and Service Fabric both, they're orchestrators. It's their job to make sure that containers are available and your service is available. So if it's running on this node and this node craps out, it lost power or whatever, Service Fabric will say, oops, I need to do something with that. It'll move it over here. If you have a bunch of data stored in that container, it's going to take a while, because there's a network there, right? These are different VMs. It's going to take a while for it to copy that over and make sure that it's replicated. So something like having data storage in a container, I think, is a great idea for development purposes. It's very fast. It's very easy. I don't have to have SQL Server installed on my laptop anymore. I can just fire up a container. But I want to make sure when I deploy it into production, maybe I have, I think it's even up here. Yeah, I'll have an external SQL database or any of these other data stores that I persist data to.
These are all protected by your Azure firewall?
They can be, yeah.
So you can create a container with a database itself.
Yes. By its contents.
Yep. Yeah, question?
It's helmsman in Greek, like government.
Oh, Kubernetes, which is weird because so there's a tool called Helm, which is used with Kubernetes. And Helm, since you brought it up, if anybody's interested in doing development in Kubernetes, Helm is something to look into. Helm helps you when you're developing your application. You can fire up Helm and basically run a command, and it will generate not all of them, there's one. It'll create a YAML file which has the definition of your application, which you can then publish into a Kubernetes cluster or into Azure Container Instance. You don't have to put together a custom YAML file and try to figure out the syntax. Helm will do that for you. As you're coding away in your application, Helm's watching you, and it updates that config, and it can push and automate that deployment. So it makes it really for a really nice development environment. The team who built that is a company called Deis. They're up in Boulder. They were a company called Deis until Microsoft bought them.
Okay.
So now the guy who started up that company is now the head of this engineering team.
Very rich.
Somebody had a question.
Yeah, so you can, it's called Helm, H-E-L-M.
Yeah.
So can you use the same YAML files for, pushing Linux into Linux boxes, I guess, as well as Azure, right?
Yeah.
Okay.
Yeah, the file itself, the format's the same. The contents would then obviously be different. Yeah. Different location or different OS, different image name.
Yeah, there's a learning curve to learn the Kubernetes, that's for sure.
Oh yeah. Yeah, so I personally, just so you know my story, I started out with Service Fabric before, about 6 months before they published it externally, which was about 2 years ago, so about 2.5 years, 3 years. I'm still learning it. They're still building stuff around it. Kubernetes, I started learning Kubernetes probably about 8 months ago, and I feel like I don't really know it, to be honest with you. Granted, it's not all I do, right? It's not what I spend my entire day on, but there's a lot there.
I don't recall you mentioning batch or app service in that slide.
Yeah, so I did mention batch briefly. Batch is used for data processing, data movement of high scale.
Okay.
App service, though, app service is a service that contains other services. App service contains, there was at least one session today talking about functions. Functions is in app service. A web app, Azure web app is in app service. Logic apps is in app service. API apps are in app service. When we talk about running containers in app service, we're really running containers today. We're running containers in a web app on Linux, which is an app service.
So quick question, right?
what's the best option to run the Windows containers out of these ones? Considering I need them to be within my own VNet.
So in production today, right? I have to qualify those two things. In
Let's
production
do
today,
Production today and production sometime in the future.
Yeah,
6 months, right?
I'll cover both. It's real easy. So these two guys down here,
Sure.
because you can have Windows Server 2016 with containers, and this guy, Service Fabric.
What can I do for orchestration of former one?
For these guys,
Yeah,
you're on your own.
on my own?
Yeah, there's no orchestration in there. You have to figure it out. Which is why this is free, remember, right? So take this, run it on that, and you're good, right? You can run Windows
We use
containers
Service
for GA.
Fabric a lot, right? I know this one, just no containers in there.
Okay. Yeah, you have to use a different image when you create the cluster. There's a specific image for Server 2016 with containers. You have to use that one. In the future, this one is going to come into the conversation
Yeah.
because they have Windows support in Kubernetes now for beta. When they go GA, then we can say we can start doing AKS with Windows.
Do you know timeline?
I don't. I haven't looked at the Kubernetes backlog for what they're working on. Sorry.
ACS Engine you can do subnets with, but that's early AKS, right? I don't think it's supported. It's here it is, use it. You make your own VMs. It works. AKS is much better, but it won't do subnets. ACS Engine will, because you get to specify exactly.
That's right. Yeah, so you can think of AKS as more of a managed service where you don't have a bunch of dials.
Yeah.
And if it doesn't have one of those dials you need, like custom subnets, you can always go to the ACS Engine route and you get that dial back. And then you can create your Kubernetes cluster.
So that's what we're using is ACS Engine.
Okay. Now, another big difference, because AKS is a managed service, Kubernetes has the concept of master nodes and agent nodes. Master nodes are the VMs that run the Kubernetes services that do all the orchestration things. They look at availability, they look at moving services around, they look at installing software. Anything that Kubernetes needs to run runs on those master agents. And then the master nodes. The agent nodes is where your apps run. So when you deploy a container, it runs on your agent node.
I'm going to report back to the master node.
Yeah, and they're talking back and forth.
So it's like monitoring.
Yeah, exactly. With ACS Engine, when you use ACS Engine to create a cluster, and you deploy it in Azure, you create both. And you're responsible for both. And you get paid, you get charged for both. You don't pay, you get charged. You should pay. AKS being a managed service, the only thing that you pay for with AKS is the agent nodes. Microsoft takes care of the management nodes for you. So the master nodes, you don't pay for those. You don't worry about them. You don't have access to them. You can still access all the management APIs, but it's not like you can SSH into the master node.
Because there's too much trouble for them. It's easier for them to manage it and not
Exactly.
give everyone access to
Yeah.
it. Master node and everything.
Right.
If you
So
want to
it's
use it,
easier.
probe
It's
it.
easier for them to manage, and in return, it saves you guys as customers money because you're paying for less compute.
Right.
Right. So that's another big difference between ACS Engine and AKS.
Like, what's a good use case scenario for this type of ecosystem? Like, why go this route?
I can give you examples. Some folks would say you should use this for everything. I'm not going to be that bold, but there are many use cases where you think of any traditional web application that you would build.
Is this for like big data and big business?
It can be. Yeah, it can be.
It's more directed to them though.
Yeah, I mean, if you're just building like my stupid blog, I don't really care if that's available because nobody reads it anyway. So I'm not going to pay for all this infrastructure. I'm hosting my blog here on the lowest level plan, which is free. And if that goes down, it goes down. But if I'm working with a company that, say, one of the companies I work with, they process your taxes. That probably shouldn't go down, especially this time of year or last week. So they're running here. And they're running here with super large scale sets with a huge number of VMs. And that can't go down. Right? So their application is orchestrated by Service Fabric to make sure that it's highly available. Now they pay for it, but
Makes sense.
so you have to figure out, where does it fit? I mean, that kind of gets into why all these different services are available, right? This is great for development. This is great for probably your internal corporate application that's up and running.
Yeah.
You don't really have an SLA for a customer. That'd be great. Because one of the other limitations here is the same as this one. You can only run one container. Make sure I'm pointing the right place. You can only run one container. If you have a solution that has multiple containers, you need to look down here.
Or like a lot of microservices.
Yeah.
If you've got a whole bunch of microservices, the middle things would work.
Yep. Now, here,
Single pane.
yes. Well, yes, you could. Here, Service Fabric obviously runs containers. That's what I've been talking about. You can also just run a service. So maybe you have an executable that you just want to host, or you want to write a service and you don't want to go down the whole container road. You can still host that in Service Fabric. It was built. Think about what I said earlier. It was built before Docker ever existed and containers were popularized. So it was built to host services. So if you're just writing microservices and you have a bunch of DLLs that you need to host, you can do that here. Here, it has to be a container. Right, so you have to get those microservices into a Docker container to run them here and here.
So I built the app as a container in my project instance stage as a dev server, and then later on moving to the environment for quality and production. Can I take that as a image copy and put it into the quality and product?
Yes, and you should.
What was the question?
The question, thank you. So the question was, I haven't been repeating any questions. Why didn't you say anything? Sorry for the people listening to this recording. The question was, when you're building an application in a container, say in a dev environment, can you take that container and then move it into, say, your staging and then production environment? And my answer was yes, and you should. Going back to the previous conversation, making sure that you're deploying the consistent thing, right? You want to make sure that that isn't changing along the route of your DevOps lifecycle. So yes, and usually that's done through, if you have a tool like Jenkins or you have a tool like VSTS, where you're using that for your source code repository and your build server, that's responsible for making sure that when you do a code publish, it'll do the build, and then it'll make sure that that build is then deployed into whatever environment you tell it to deploy to. It's not doing a test build and then doing a deployment, doing a production build and doing a deployment. It does one build and multiple deployments with different configurations. That's ideal. I know that's not always the case for a lot of folks, but that's ideal. Yes, sir.
How much of that ecosystem can be self-hosted on Windows Server? And I was kind of curious to know what's happening, what's the plan for the service bus?
Service bus. That's a left field question. Okay. All right. So the question was.
Apple?
What's that?
What do you think about Apple?
We'll talk later. So the question was, what's the story for running these services on a local Windows server? Yeah, go ahead. So Service Fabric can run locally, no problem. It was built to do that. You can even run this in AWS if you want to, which there are some customers doing. Kubernetes won't run on Windows yet. So when they build that out, then theoretically you could run it on a local Windows environment in your data center. Container instance, no. App service, no. So I guess these are the only two. Now, if you're just looking to, say, host a container and you don't need all the orchestration goodness that Service Fabric and AKS give you, Server 2016 supports containers all day, every day. So that's not a problem. You just won't get the orchestration of, if this VM goes down, there needs to be something else to move the container and fire it back up in another VM.
And that's what I thought Service Bus was providing in the older Windows servers. And you could host that yourself.
So Service Bus is more for messaging and communication between services. Those services could be Windows services. I suppose you could use it.
And not also orchestrating?
It is. Yeah, it's not orchestrating at an application level, right, where it's taking bits of an application, making sure that they're up and running, and you expose a port, right? It's not doing that.
Okay.
It's more, this application uses this piece of data, and I need to make sure that that's also located over here, so I'm going to send it across the bus to a listener. So there's also Azure Service Bus, which is another service, which is something different. Right, so there's two. All right, I think I'm over time. Because he's walking up here.
They're enjoying.
All right, I'll be around the rest of the day if anybody has any questions. Hope this was useful.
It was very important.
Now,
Thank you.
everybody asked a question over time has to stay in my session. Houston, that makes sense. Palm trees, that fits. It's supported, yeah. Houston. Houston. Have a picture. Knowing that. That's fine. That's great. Yep.